How do power meters work? Part 9 of 10. All right. So we're going to talk about a quick little history lesson. The first multimeters, we've already gone over the voltage deflection, right? And so now we've taken all of those and we've put them into 1 meter, right? So here's all of our currents right here. Here's all of our resistances right here. Here are all of our voltages right here. And there's other features that this meter does. Let's not talk about that right now. But as you can see, you have your ohms. That's the top scale right here. Then you have your voltages right here. And at the bottom, you have your AC is what I mean, your amps. Okay. So you can see that you're clearly able to measure all of them. And we have calibrated the internal resistors to work with this scale and make it so that way one single printed background works for all of them. Okay. So yes, did it require some planning and some math? Yes, it absolutely did. And so this circuit was hand selected with all of its parts so that way each scale would work appropriately. For example, if I wanted 250 millivolts, right, if I selected it there, that means I'm going to measure anywhere from 0 to 250. And I would use the 0 to 250 scale, which is right here, right? So this is the scale that we're looking at metering with, okay? So you just have to make sure that you're looking at the right scale. That's what this means, okay? And make sure that you look at the right selector. Remember, always start at the highest value and work your way down so that way you don't smoke your meters. This if you started at 50 and you were measuring something that was 200 volts, this needle would peg out all the way to the max, and hopefully you didn't smoke your meter. All right. So as we said, start with the high end and don't burn it out. Okay. And this is kind of what we're looking at, and this is what the internal setup for this guy could look like. Okay. These are the hand selected values. And that might actually be the hand selected value is 990 kilo ohms. And we've selected a few other resistors and sized them just appropriately with a potentiometer so that way we can calibrate this overall run. Okay, so there's other ways of dealing with this. Current scales can also be selected, as we said, selected, start at the highest. This one is 100 milliamps, 10 milliamps, 1 milliamp. Start at the highest current possible, okay? And that way you can prevent yourself from smoking your meter. The last one is notice the needle position, right? We're going to talk about resistance right here. And if you notice something real quick, 0 to 100 volts is right here, right? So this is the most positive, and this is 0 right here, right? Or this is the highest or whatever, right? For voltage and for voltage and current, right? But if you look at resistance, it's the opposite. For resistance, this is the 0 ohm side, and all the way over here is maximum resistance, right? So this is the greatest resistance side. Does that make sense? Well, absolutely, it makes sense, right? If I said I had 0 current on this I equals 0 over here, I would expect me to have very high resistance, right? And if I were to have a really high current on this side, I would expect to have practically 0 resistance, right? Because voltage divided by resistance equals current. If the resistance is 0, then the current is really high, okay? So these absolutely make sense. And if you ever use like an old megger or ductor, what you'll notice is that these scales are not necessarily intuitive, and you have to really read what you're looking at in order to get the numbers accurately.